Applications like dashboards and analytics tools often can't use external data right away as the formats don't match. Imagine Company A trying to analyze Company B's supply chain. B stores the data in 4 CSV files, but A's system only accepts 2. Even though the information is the same, B's data has to be reshaped into A's format through numerous complex transformation steps before the data is even usable. These kinds of data mismatches show up all the time, and fixing them usually involves a lot of manual effort to understand the data and write transformation scripts. This process is time-consuming, error-prone, and doesn't scale, and thus automating such data conversion process is critical. We present DataSpeck, an AI-driven human-in-the-loop system for automating transformations in data conversion workflows. We will now demonstrate our system by solving the same data conversion scenario described previously. We first load the specification datasets into our system, which represents our target data structure. Our system's interface displays the loaded data, the associated metadata, and fields to input data descriptors for each column. Once the specification datasets are loaded, our system analyzes the data and populates the dataset descriptors. By sampling only a few rows, our system is able to infer data formats, data units, and even complex data structures. Furthermore, our system provides a reasoning to support each inference. The user can manually edit any descriptor if they want to, and that gets stored as a user-provided context. After this, the source datasets, which represents the data that needs to be converted, are added to the system. For this example, Company B's dataset, which consists of 4 CSVs, each containing approximately 100,000 rows, are added. The interface is similar to that of the specification dataset, and the same analysis is repeated by our system. Once the datasets are loaded, our system can start designing the conversion pipeline, which is generated for each specification file individually. Our system first tries to establish a semantic relationship between the source and specification data and strategize how to create data for each column in the specification dataset using the source dataset. For each column that it is confident about, it displays a green check mark along with its strategy to generate that column. There can be situations where our system is not confident about certain strategies, in which case it asks the user for clarification. These situations are displayed using a yellow warning symbol, and the user only needs to respond to the specific queries made by our system. Once the clarification is provided, our system begins to autonomously generate the conversion pipeline in a step-by-step order and displays the description, code, and output of each intermediate step. Our system stops generating the pipeline once the particular specification dataset is recreated using the new data source. The steps are repeated for the second specification dataset. In this scenario, we observe that the system seeks clarification on the exchange rate between US dollars and euro. We also see a red cross next to the column packaging requirements, indicating that the system does not know how to create this column and needs additional context. In this case, packaging requirements is calculated using a specific binning threshold. Again, after all the issues are addressed, the system starts to autonomously generate all the conversion steps. It can be observed from the code that the system uses the provided exchange rate and binning thresholds. Finally, there can be situations where the user needs to perform custom transformation steps. In this case, the user can simply click on the plus icon and describe the steps in natural language, and this step gets added. Additionally, the user can also modify any intermediate step if needed. Once the user is happy with the conversion, the converted dataset along with the generated pipeline can be saved on the user's system. Our system tries to come up with a logical solution when generating a data conversion pipeline. However, there can be scenarios where a logical solution is not possible. Consider this scenario where the specification dataset consists of multiple address fields, whereas the source dataset consists of a single column containing the full addresses. To convert the source to specification, components of the address need to be extracted. However, since the full addresses do not follow any specific format, it is not possible to write a logical code to perform the conversion. Our system identifies such situations and suggests using the AI-powered function, where each row is sent to an LLM with a prompt to return the necessary information. However, Since such operations can be expensive, the user needs to give permission to use this function. Once the permission is granted, our system writes the necessary prompts and fetches the required information using the AI-powered function. By automating the entire process of data conversion and only involving the user in case of uncertainties, our system significantly reduces user overheads.